Namaste and welcome to day 3 of 30 days of Appwrite. We are continuing along with the official 30 days of Appwrite, learning similar concepts, and will be building a Flutter application. On day 1, we talked about what 30 days of Appwrite is and what Appwrite is. On day 2, we learned how we can install Appwrite. Today, we are going to look at the set of microservices that make up of Appwrite, what Appwrite is made up of, and what each microservices do. So let's look at this diagram. You can see here is our Appwrite deployment. We can connect to Appwrite using web, Flutter, iOS, Android, or any server-side applications as well. So we have a load balancer. So as a load balancer, we are using traffic. We'll look at that in a bit. And we have a console, we have APIs, then there is a security layer that checks for authentication and authorization. Then we have cache, PubSub implemented using Redis. Then we have time series data, stats, using Telegraph and InfluxTV that shows us usage statistics. Then there is antivirus. There are certain things like scheduler, certificates handler, functions, webhooks, tasks, mails, audits, and other services. So we have different services including users, accounts, teams, database, storage, localization, avatars, and health. So let's move on and look at each microservice that comprises the Appwrite stack and what each of them does. So the first one is the Appwrite, the main Appwrite container. It provides the Appwrite API and also performs authentication and authorization, also helps in rate limiting to protect abuse. This service is completely stateless and can be easily replicated. Next, traffic. So traffic is a modern day reverse proxy and load balancer that we use. It configures itself automatically and dynamically. It integrates perfectly with your existing stack, and it is the main entry point for any request coming outside of Appwrite. Next, Redis. Redis is a in-memory database, and we use Redis in Appwrite for caching, PubSub, and scheduled tasks, any scheduled future tasks that Appwrite handles. There are other services that run from inside the Appwrite container but as a separate service, and each of them have specific tasks. So let's look at those. First, the audit worker or audits worker. It consumes the messages from audit queue. Okay, we have a queue called v1 audits, and audits worker consume messages and then set of events that Appwrite has configured. Whenever the events occur, the audit worker add the logs inside MariaDB, and audit worker uses Utopia PHP audit library. The link is provided in the description. Next, we have certificates worker. It consumes the masses from v1 certificates queue, and the certificate workers uses certbot from Let's Encrypt to create and periodically renew SSL certificate. We'll cover more about SSL certificates in upcoming days. Next, the delete workers. The delete workers consume the masses from delete queue. As the name suggests, it is supposed to perform the delete operations in Appwrite database. Delete requests to documents, users, projects, functions are all handled by delete worker. So in the present state, delete worker is triggered on certain API requests as well as by maintenance worker. Next, we have functions worker. So functions worker again consume from functions queue and handle all the tasks related to Appwrite's cloud functions. Cloud functions in Appwrite can be triggered in 3 different ways. So it can be triggered asynchronously using events. It can be triggered using a cron schedule, and it can also be triggered using the HTTP API. The functions worker does all the heavy lifting required to get Cloud Functions up and running. That includes pulling the Docker image for respective runtime environments on a startup and managing the running containers, responding to errors, and providing outputs. The functions worker takes care of it all. Next, we have mails worker. It consumes from mails queue and is responsible for only one function, sending email. It simply gathers information and uses mail script to send those using the SMTP service that is connected with the Appwrite. Next, we have tasks worker that consumes from task queue. Task API allows you to schedule repeating tasks that your app can run in the background. Each task is created by defining a cron schedule and can target an HTTP endpoint. Each task can define any HTTP endpoint with any HTTP method. They can also send HTTP headers and authentication. From inside Appwrite console, you can view all your tasks, current status. You can create new tasks as well as delete existing tasks. We'll look at those in the upcoming episodes. Next, the usage worker consumes messages from usage and makes use of stats to send messages to Telegraph. The usage stats are then logged into InfluxTV, including function execution stats, total number of requests, etc. regarding your Appwrite project. Next, the webhooks worker. The webhooks worker consumes messages from webhooks queue and triggers the webhooks that are registered in the Appwrite console. The worker checks for events that occurred and fires the corresponding webhook by using a crawl request. Webhooks allows us to build up an integration which subscribe to the event. For example, you can trigger a Slack message depending on certain events on your Appwrite instance. Or you can integrate to any service that provide webhooks using the Appwrite's webhook service. The maintenance worker corresponds to the Appwrite maintenance service that is supposed to periodically perform some housekeeping tasks on the Appwrite server. So, the maintenance server worker delegates the actual deletion. We use maintenance worker to only schedule deletions and other tasks. So, maintenance worker schedule 3 kinds of deletion. So, it cleans up abuse logs, it cleans up audit log, and also cleans up execution logs. Finally, we have a schedules worker, which I have missed in the list, but we have a schedules worker that uses rescue scheduler under the hood and handles the scheduling of all the cron jobs like functions cron or tasks cron or even webhooks API. So these are the Appwrite workers that work under the hood to make Appwrite awesome. Next, we have MariaDB. So right now, the default database is MariaDB that stores all the projects, collections, documents, and all other metadata for our Appwrite instance. However, Appwrite is agnostic to the database under the hood. You can support any database. So support for more database is coming up. It's currently under active development. You can see the progress in the GitHub. ClamAV. So ClamAV is a TCP antivirus server. It is responsible for scanning all the user uploads to Appwrite storage. It is optional and can be disabled using environment variables. You can find tutorials regarding that. And starting from 0.8 version, it will be disabled by default, but you can enable it easily. And disabling antivirus will not compromise your Appwrite server because any files in the storage are not executed. It is only for the sake of your users that scanning the storage files is safe if your users are downloading those files. Next, we have InfluxTV that provides the API usage metrics and stats, generates the graph that you'll see on the dashboards in upcoming episodes. Then we have Telegraph. It's an agent for collecting and sending metrics events. It collects all the events or metrics and statistics, and before sending it to InfluxDB, it aggregates the data and sends it to database. It operates on UDP protocol, and so these are the microservices of Appwrite that make Appwrite awesome. Here are some handy links that you can go if you have problems during 30 days of Appwrite or in the future. You can go to the 30 days of Appwrite website. You can visit the Appwrite official docs. You can visit the Appwrite on GitHub, and you can join the Appwrite Discord where we are actively helping each other. Thank you for watching this video, and see you again in the next episode.